Afternoon, guys. In this session, we will be having a look at chemical bonds, and more specifically, we will have a look at covalent bonds. So, when we talk about bonds, we talk about a reaction that took place between two elements or atoms of that element, and that formed a molecule. We get different types of bonds. The first bond that we get is a covalent bond. Then we get an ionic bond and a metallic bond. In this session, I'm just going to explain to you what a covalent bond is. Now, a covalent bond forms between two nonmetals. So whenever you have to go and determine which one is a covalent bond or ionic bond, the first step to go and determine whether it's a covalent bond is to go and check whether it's formed between two nonmetals or a metal and a nonmetal or between two metals. So you need to have your periodic table handy and you have to know which ones are your metals, nonmetals or semi-metals. I'm going to use this periodic table that we used previously. Remember guys, most of the elements on this side are your metals. These ones are your nonmetals, and then here in the middle we get our semi-metals. What is important is we will ask you guys to go and draw these bonds and how they're formed. You will also see in the page that I've printed for you guys exactly what a bond looks like and also what a covalent bond looks like. Now, it is important to know that we have three types of covalent bonds. We have a single bond, a double bond, and a triple bond. Now, whenever a bond is formed, there are always pairs of electrons present. So, when we have a covalent bond, certain electrons are shared between the atoms. All right? So, when we have a single bond, it means there is only one pair of electrons that are being shared. If we have a double bond, it means we have two pairs of electrons that are being shared. So it's not just two electrons, it's two pairs, like a pair of shoes. There's always two of them. So if we have two pairs, it means we have two and two together. And then we also get a triple bond, which means we have three pairs that are being shared. Now these dots that are being shared are the electrons. All right. In the previous session where we explained to you the valence electrons. Remember, when bonds are formed, only valence electrons we're only talking about valence electrons. All right. So when we're talking about pairs of electrons that are being shared, we are referring to valence electrons on each atom that are being shared. All right, at the bottom here, you will see that I put out steps for you guys to determine whether we're going to have a single bond, a double bond, or a triple bond. Now, if we have a pair of electrons, we can also indicate it in the form of a dash. You can just draw lines as well. So instead of drawing two dots, that dot can be a line as well. You can draw them like this. So if we have three, you draw three lines as well. Now, it is extremely important to use these rules to determine how you will draw your bond that formed. So the first thing that you need to do is you need to go and determine how many valence electrons each of the atoms have. All right. Now let's say, for example, I ask you to go and indicate or draw the bond that took place between two chlorine atoms. Then you go and draw your two chlorine atoms. You're going to draw chlorine. Then you're going to go and look on the periodic table to determine how many valence electrons chlorine has. So let's go to our periodic table. You find chlorine there. chlorine is in group 7, which means that chlorine has 7 valence electrons. Now, we have 2 chlorine atoms. Let me take another piece of paper so I can draw it this way, just a little bit bigger. Okay, so we have chlorine here. And I asked you guys to draw the bond between 2 chlorine atoms, right? So then we say chlorine plus another chlorine. Okay, so my first step to determine how to draw this bond is going to be determine how many valence electrons each of the atoms have. Now we did that. So we determined that chlorine has 7 valence electrons. So go and draw your 7 valence electrons as you would 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. The next step that you're going to do, draw the Lewis diagram. We did that. So we determined the amount of valence electrons. We drew the Lewis diagram. Now, step number 3 is extremely important. Count what is the total amount of electrons that the bond can have. So after this bond has formed, you see here, we have 7 valence electrons here and 7 valence electrons here. So we can only have a total of 14 electrons after this bond has formed. And this comes into play specifically when we go onto double bonds and triple bonds. All right, we've done that. Now we're going to go and pair up. So the most important thing that I need you guys to remember is when these 2 chlorine atoms combine or bond, after the bonding took place, both of them must have 8 electrons around them, but only a total of 14. So now you are thinking, but if this one has 8 and this one has 8, we're probably going to get up to 16. But remember, they are sharing electrons. You can already see here where the sharing is going to take place. Look at this one. Okay, there's a spot there and there's another spot there. So it's probably just going to fit in like a piece of Lego into each other. So you say chlorine plus chlorine, draw your arrow. Then you draw the 2 chlorines next to each other. And 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So now you can see here, they are sharing electrons. Because let's go and look at my first chlorine and count whether it has 8 electrons around it. Go look, remember on your steps, go and make sure that it has 8 electrons after the bond took place. So let's go and count. Here's my first chlorine atom. 1, 2, 3, 4, 5, 6, 7, 8. Good. And then my second chlorine, there. 1, 2, 3, 4, 5, 6, 7, 8. All right. So you have to go and check whether both of them have 8. And the second thing that you need to go and check, you need to go and check that there aren't more than 14 electrons around this bond or in this bond. So let's go and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is an example of a single bond. Okay. Now I want to show you guys an example where we will have a double bond. So this is where it becomes very important that you count the electrons beforehand, before you start bonding and working out. So let's say, for example, I ask you to draw the bond between 2 oxygen atoms. All right, let's follow the steps. Do you have your steps next to you? The first thing, we're going to determine how many valence electrons each of the atoms have. So we go and draw our oxygen atoms, oxygen plus oxygen. Go to your periodic table. Here's oxygen. Each oxygen has 6 valence electrons. So we go and draw them. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. The third step, we are going to go and count what is the total amount of electrons that we can have after the bond took place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we cannot have more than 12 after this bond has taken place. That's the first thing that we're going to check. And the second thing that we're going to check is that both of them have 8 electrons around it after this bond has been formed. So here's what's going to happen. You are going to go, let's go and try to form a double bond. 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen now has 8 electrons around it. 1, 2, 3, 4, 5, 6, 7, 8. All right. So let's go and count. So this oxygen here has 8 electrons around it. 1, 2, 3, 4, 5, 6, 7, 8. And this atom here, this oxygen atom, has 8 electrons around it. So that is pi now. Let's go and make sure that it doesn't exceed 12 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 electrons. So that is an example of a double bond. So you're going to have to play around with it a little bit. But remember, guys, practice and repetition will, once you've practiced it a little bit, you will start to understand or start to see sort of kind of when we're going to have a single bond or a double bond. I just quickly want to do a triple bond with you guys to end off. So let's say, for example, I ask you to draw a bond between 2 nitrogen atoms. Okay, let's go and follow our rules. We go and count the valence electrons around each nitrogen atom, and then we go and draw the Lewis dot diagram for each one of these ones. So let's go to our periodic table. Here's my nitrogen. Nitrogen has 5 valence electrons. So we go and draw it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. Then we have nitrogen, nitrogen. Okay. First thing, let's go and check what is the total amount that we can have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We cannot have more than 10 electrons after it has been formed, the bond, and each one of them need to have 8 electrons around it. So I'm going to go 1, 2, 3, 4. So now each one of them has 2 already, so they still need 6. So if you go and draw 6 around this one, this guy is not going to have 8 as well. So here is where our triple bond comes into play. Okay, remember they're sharing these electrons. So this nitrogen atom now has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And this one has 8. 1, 2, 3, 4, 5, 6, 7, 8 electrons. Let's go and check that there's no more than 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorted. So those are your examples of your single bond, your triple bond, and your double bond. Use these rules that I gave you guys in the notes to go and determine whether it's going to be single or double bond and how to draw these diagrams. I will also include these pictures for you guys. There are quite a few of these in your notes already that you can refer to. Okay, that is covalent bonding. And on the last page of covalent bonding, there are a few exercises that you can do on your own to go and determine whether it's going to be single, double, or triple bonds.